Hi, this is Zach Anderson, and today I will be going over problem set number 2. So per usual, let's begin with going over the requirements and what we're supposed to look for. So a lot of words here. If you would wish to read it, then that's the beautiful thing about YouTube is you can pause and read it. But what we really need to know for this is we are testing our code with a balance of 5,000 and an annual interest rate of 0.18 or 18% for the subproblems below. So like I said, if you want to read it, pause it, but let's continue. So problem 1, paying debt off in a year. So write a program to calculate the credit card balance after 1 year if a person only pays the 2% minimum monthly payment required by the credit card company. So the following variables are what we're going to need. So we need a balance variable, an annual interest rate variable, and a monthly payment rate. And then this 2% minimum monthly payment is also very important, and I will explain why shortly. For each month, we are calculating the statement on the monthly payment remaining balance at the end of 12 print, and then no more than 2 decimal digits. So this is just giving the example of, print this instead of this, hence the 2 decimal places. So this is just a summary of the required math. We have the monthly interest rate, the minimum monthly payment, the monthly unpaid balance, and the updated balance each month. So if we head over here, we can get right on into our code. So we have our variables up here. So balance is set to 5,000. The annual interest rate is set at 18%. The minimum monthly rate is at 2%, which is where we saw that up here, the 2% minimum monthly payment. And then we have a month counter set at 0, and I will explain why in just a moment. So here we have a while loop. So while month is less than 12, and this is going to help us iterate through all 12 months of the year to get the remaining balance at the end of said year, so at the end of 12 months. So this right here adds 1 to the month variable every time that it is run through, which will, again, total 12. So each of these blocks does something different. So first, we calculate the minimum payment amount. And to do this, all we have to do is multiply the current balance by the minimum monthly rate, which up here is 2%. So it's just going to take 2% from what the current balance is, and that'll be the minimum payment. Next, we need to subtract that payment from the current balance. So whatever rate we get up here, we just subtract that from the current balance. Then after that, we calculate the monthly interest on that remaining balance, and that is done by this equation here. So multiplying the balance by the annual interest rate divided by 12. So 12 just for a year. And then we add that interest back into the balance to get the quote-unquote true balance. And then after all of that, all we have to do is print. So we have a statement here, the remaining balance, and then this right here is just to format it into 2 decimal places, and then we print our balance. So if we were to come up here and run it, boom, we get a remaining balance of $4,691.11. Okay, so now problem 2, paying debt off in a year. Write a program that calculates the minimum fixed monthly payment needed in order to pay off our credit card balance within 12 months. By a fixed monthly payment, we mean a single number which does not change each month, but instead is a constant amount that will be paid each month. So in this problem, we will not be dealing with a minimum payment. So this will just be a fixed payment, so the exact same thing every month. And the goal is to calculate what that lowest potential payment can be. Similar to the last one, we have down here the math we're going to need. So we're going to need to calculate a monthly interest rate, a monthly unpaid balance, and then an updated balance each month. So let's head over to the code here. So up top, we have all of our variable declarations, our balance, our annual interest rate, our month counter, an initial balance, which I'll explain down below, a minimum payment amount, and then a monthly interest rate, which we saw in the math. Now, this minimum payment amount is going to be in sets of 10, and this is because, here it is, the monthly payment must be a multiple of $10. So since it has to be a multiple of $10, this sets our lower bound right here of just what we can possibly start with. So that's why we have it initially set to this. So this outside loop, while balance is greater than 0, minimum payment plus equals 10, balance equals this initial balance variable, which I declared above. This is the main loop that finds the minimum monthly payment right here. It keeps running as long as the balance is not zero, hence the debt not being fully paid off. So this line right here increases the amount by $10 after each iteration it goes through. And then this balance equals initial balance is resetting the balance back to its initial, so 5,000 at the beginning of each iteration. So this is allowing for recalculation with a new minimum payment. And after each iteration, I mean after all of this goes through. So next we have this while loop down here, which is considered the inner loop. This is for iterating through the 12 months of the year. So this statement right here is going to add 1 month each time that this gets activated. So this will go through 12 times. This line right here calculates the new balance after a minimum payment is subtracted. The next line is going to calculate interest based on the new balance or the current balance that we have while the problem is running. And then it will add it back down here to get our true balance. And this month resetter is resetting the month count to 0, and this allows the simulation to start fresh. So similar to the initial balance reset, this just gives us the most accurate calculations for each iteration that it runs through. And finally, we have our print message, so the lowest payment, and then which would be held in this minimum payment variable. So if we go ahead, we'll scroll up here. If we go ahead and run this, we see that we get a lowest payment of $460. Problem 3, we are going to be using by section search to make the program faster. So super self-explanatory up here. This is just kind of going through what it really means. Calculating a more accurate fixed monthly payment without running into the problem of slow code, hence the by section search to increase the speed. So we're going to need these two variables. This is talking about a lower bound and a upper bound. Down to the calculations we're going to need, so the monthly interest rate, the monthly payment lower bound, and the monthly payment upper bound, which this looks a little complicated, but in reality it's not, especially when implementing the code. So let's head over here to problem number 3. So up here we have all of our variables declared per usual. Balance of 5,000, our annual interest rate of 18%, designated by the 0.18. Our month value is at 0, like the other problem, so when we use it down below we can iterate easier. The monthly interest rate, which is designated by this equation here. And then as we just saw in the problem over here, the lower bound and upper bound equations. And then similar to what we did up there, the original balance being tied to that balance, and you'll see how that works down here. So this first while loop is the outer loop, which is used to calculate the lowest monthly payment, and this is using a binary search. So this while loop is going to continue to run until the balance is paid off. So it'll iterate until it finds that whatever. It's in a sense it's like the precision of floating point. That's the best way to say it. It's just running until we're as close to 0 as possible. So that's why we're using this 0.01, the 1 cent. The variable I right here is the midpoint between lower and upper. So it's basically just the trial monthly payment that the code is actively testing. And then when we are resetting the balance to the original, like I said up there, the original holds that original balance of 5,000. This reset is necessary just for each and every trial that we go through. So this second inner loop right here is similar to what we did up top. It iterates through the months. So we have our month variable set to 0 above. So while month is less than 12, and this will add 1 every time that we go through the loop until it gets to 12. This will subtract the monthly payment I from the current balance, and like we said, I is the number we're currently testing to find the bound or to find the payment we want to do. And then we're calculating our interest based off that current balance, and then we calculate the quote-unquote true balance after adding that interest back in. And then Similar to resetting the balance to its original, we also reset the month count for each new simulation or trial. Then with this block down here, we are adjusting the bounds. So this is kind of what this is saying. So if the balance is less than or equal to the 1 cent mark we have here, then the current payment is likely high enough to pay off the debt. So in that case, we are going to set the upper bound equal to I, which is just lowering the upper bound and searching for that payment. And then it's the same thing down here where if the remaining balance is still positive, so greater than 1 cent, that means the payment was too low. So then we're going to tie this lower bound to I to raise it and then to search for that larger payment. And then to finish it off, we are going to rounding the balance to decimal places. So this is just for looks, and then we print that final answer here. So if we were to run this code, I believe it's already connected. Perfect. Just right away, 451.62. Thank you.